pin number is pin 1. Okay, so the same it should be here also. Okay, pin number it should be connected. Okay, so this is a ECU, the front end, whatever you are seeing here. So this is a part of the ECU. It is like a pin diagram. It shows like this, and the actual ECU it will be like this. Okay, so this will be a part of the harness and wires from the power supply. We are directly connecting to the ECU, whichever you saw the previously the ECU. So to communicate with the ECU, like what are the information it have? So it have the application software. So it have the application software and boot software. What is a boot software? Boot software is specifically to boot up the application software. The boot software is required. So it is having the configuration of the hardware configuration will be there, and the scheduling will be there. So and moreover the base software it will be there in the boot. So moreover, on behalf of that, we are flashing the application software and the boot OS, boot software will be there. So generally this is will be there. So for flashing the boot software, it is a different procedure where we need to use debugger tools and flash it. Application software we can flash directly. So all this will be configured in the ECU. Next will be the part of the communication with this ECU. Like we are taking the PC. So we usually say lab PC, and with the help of CANcase Excel, we can exchange the information, like whatever the TX messages or RX messages that we can do, we'll do it. And we have the CANoe simulation. With the help of the CANoe simulation, where we can give the input to the ECU and uh, like whatever the varying of the input values that we can do via the simulation. And we have the TX and RX messages that is related to the lean messages or the CAN messages that we can be updated. And flashing tool for flashing the software. Flashing the software. Flashing the software, we are using this. So this is a lab PC. So from here, we are configuring to the and communicating with the ECU. Like as usually, like we usually follow with the system with the CANoe, and just you are plugging into the CANcase Excel and ECU. So for communicating with the ECU, you need to ensure that CANcase Excel is required, because here you are using the CANoe vector tool. If you are a vector tool, so then you need to use a vector tool for communication purpose. Is it clear? This is a open loop bench setup. Okay. Next, when we then the bench come up with the additionally like the load box. So the load box, what is the purpose of the load box is so because in the previously we don't have the real signals, real physical inputs. Okay, so with the CANoe we are doing simulation. Here the load box, it consists of all the analog inputs, digital inputs, and pulse frequency inputs we can give, and moreover the communication of IOs. So just we are doing from the load box. Okay, so like we are giving the power supply to the load box, and from here we are externally communicating with the ECU, because this ECU expecting some physical value. So like whatever we saw the harness, we are, because this harness is a group of wires, bunch of wires, we are communicating with it. Group of wires, it have consist of all the uh, specific inputs, digital inputs, frequency inputs, and communication IOs, and moreover, like we have the power supply also, power supply and ground. So usually it have the load box, and from here we are giving the harness to the ECU. And next, same thing we need to monitor on the lab PC. So here, like, so we do the UDS, TX and RX messages of the LIN, CAN on all we do, and CANoe simulation and flashing tool. We have a we flash tool for flashing the software, and additionally, like fault injection we'll do, and we are able to vary the physical inputs. Means we are able to vary the physical inputs of the analog input and the digital switches with the help of the load box. And moreover, we can induce the fault. Means suppose here you have the sensor like analog input. So this analog input, you can give the short to battery, short to ground. So like you can take the additional wire and just you have a option of a ground battery will be there. So just you can plug in, plug out. So that fault injection you can do on the load box. So this is a open loop bench setup. So for this lab PC, we are communicating with the same like CANcase Excel for inducing the faults or varying the physical inputs on the load box, so that we are doing it. Okay. And next is coming to the HIL. HIL is a closed loop system. So here we have the power supply of 12 volts. What is the HIL? So HIL, it have the processor card. Processor cards will be there, and IO cards will be there, and FIU cards will be there. So processor cards, so specifically it is to process the data, and IO cards is for communication purpose, and fault injection is specifically to induce the faults related to the sensors and related to the digital inputs, digital outputs. Okay. So then IOs. So for the IOs, we with the help of the IOs, we are using the harness to communicate with the ECU. So our ECU, it have application software and boot software, and to communicate with the HIL to the ECU, additionally, the CAN communication is must and use with the help of CANcase Excel. From the HIL, we are connecting to the ECU. And in the to access this lab HIL system, so we have a simulation tool. So will be there. The can like depends upon the HIL PC, the tools usage will be differ, and flashing tool and plant model will be configured. So for communicating with the lab PC in HIL, we are using the Ethernet. Ethernet is a protocol for fast accessing of the data, for fast exchanging of the data, or for communicating with the HIL, we are using this. So apart from that Ethernet protocol, we can use the fiber optic also. So this is a way faster than the Ethernet, but generally like most of the HILs like we are using, so it will be Ethernet protocol. So this is about the closed loop system. Is it clear? Next, coming to the, we need to understand what is the software, what are those, what is the system. So we need to go in detail. So what is a software? So software is instructions or program data, so that able to operate the computer, and we need to perform a multiple tasks. What are the types of software? System software, where it manages the hardware and device drivers and operating system. And application software, it is the end users, where used to perform the like productivity or media or gaming, some part of a end users to perform specifically application software. And embedded software are like the mobiles or any appliance like washing machines and DVD players. So some of the applications where it requires the OS and the application and it combination of the hardware. So and midware. So it is a bridge between the hardware and software components. So from where it is a specifically the boot level we can say. So from where it will control the hardware functionality at low level. Okay, so just to give you info on software, what is the specifically the system software, application software, embedded software, or midware software, firmware software. So there are different levels and types it will be there. And moreover, what is a system? So system, it typically refers to the object or the process that being controlled or manipulated. Means so it usually where the system it talks something it should do work. Okay, so if you take the drone, drone is also one part of a system where it able to fly and able to move the one place to the another place. So it is a part of a system. So it's referred to the object or a process. Okay. So what it able to do and what it able to process. So how it should be controlled via the remote, right? So the whatever the inputs we are giving. So we with the help of the inputs we can manipulate. Means we can change the inputs. So that is a system, and the system is a collection of components. This is the definition you need to be remember. So collection system, if someone asks you about what is a system, so system is a collection of a components or elements that are interconnected and work together to achieve a desired outcome. So that is what is a system. So and system, it will be divided into subsystems. Okay. So whatever the systems will be there, right? So the systems will be divided into subsystems. So it is a multiple subsystem combination will be formed as a system. So collection of subsystem that supports the larger system. Means like if you take the drone, you have the fans, motors. So that are subsystems. So one fan and motors are one subsystem. The four motors and the controller, it will be placed. So way to operate and moreover the remote. So all are subsystems and we make it a combine, then it will be formed as a system. The outcome includes the regulating some variable inputs and the other like whatever the inputs we are giving based upon the inputs, the output will be varied. Okay, so that will be acts as a system. And next is what is a system in terms of embedded system. So typically it refers the both hardware and software combination. So to perform the specifically on the product, okay, on the device. So that will be referred as a system. What is a system in terms of automotive domain? So in automotive domain is specifically on the on-road vehicles. So where system refers the collection of components or the model within a vehicle. So that work together perform a specific function or the task. Okay, so moreover, the way vehicles which we are using. So in earlier days, the operation specifically to perform some application like wiper system or seat control, it have individual uh, separate controllers. So to operate that, it's very difficult. So now uh, we came up with the safety and comfort and operation of the vehicle. Things and performance should be very easy nowadays. And to ensure that the vehicles, so whatever we are operating, it should follow some desired inputs and desired outputs. So from that, we came up with the control system. So how we are able to control the system. So control system is a system in which the output is controlled by varying the input. Okay. So and moreover, so and what is a control system and what is a control loop system? So control system is specifically we decide and adjust to keep things on the track, or like we whatever the temperature we need to give, so that can be decided and we can adjust accordingly. Okay, so like I need 24 degrees centigrade, so you can adjust. Okay, so you can keep in your mobile, like so in your system, like if you have a AC, so from the remote you are able to operate. Okay, I need 24 degrees centigrade, you can adjust it. So that is the decide and adjust to keep the things on the track. So that will be part of the control system. And what is a control loop system? So the control loop system is it will automatically adjust. Okay, so like if the room outside the temperature is increasing 44 degrees, and now inside the room temperature based upon the outside temperature, it it will be always constant. It will always maintain 24 degrees centigrades. The room temperature means whether it increases or outside or not a difference. So only the thing is inside the room temperature it is operating the same, means it automatically where it will observe and it will adjust automatically. So the cycles of checking and adjusting keeps the everything on the track, that controls the loop system. Example like for the control system is the smartphones. Okay, so where the smart thermostat adjusts the heating system based on the room temperature and maintaining the comfort. And example for the control loop system is, it is same, like continuously it will monitor and it will uh, adjust the inside the temperature. So due to the where we don't want the manual presence, control loop system. Or what are the types of control system and control loop system? So the types of the control system is open loop control system. So operates without feedback. Okay. So we don't have in the controllers where we have the controller specifically, like we saw earlier, like we have the CANoe, and from the CANoe we are operating our ECU, right? So this will be a part of a control system. So with the CANoe, we'll give the inputs and we observe the outputs. That means transmit TX and RX will be observed in the open loop system. It won't have any feedback mechanism in it. And next is a closed loop system. So it based upon the feedback, it have the feedback mechanism. So based upon the feedback, the output will be varied. Okay, and input is controlled. Okay, so uses feedback to adjust the input and maintain the desired performance. And next we have the other types of control systems. So linear control system. So input and output relation follows the linear principle. But in our scope of embedded system, like whatever we are using daily ways, so for automotive, we follow the open loop system and closed loop system. And we have a linear and non-linear. So non-linear is a relation. It is a specifically the input-output relation with a non-linear and requiring the special. It have a specialized methods in it. And the discrete control method, it operates on a discrete time intervals. It in a digital way. And continuous time control system, so where the it requires the continuous in the time to operate. Okay, it depends upon the time that whatever the signals we are sending. So our scope will be the open loop system and closed loop system. So to understand you what are the types in it, we have the control system. So just it is a info for you. And here the important points you should remember and make a notes is the open loop system and closed loop system. And what are the control loop system? Means this cycle checking and adjusting, it keeps everything on the track. So that's the control loop system. What are the types of loop system? So propulsion integration derivative, that is a PID control system, because this will be used in a higher mission industries. Okay, so to operate the higher equipment, so they will do this. So adjusting output based on the propulsion and integration and derivative terms. Okay. So next is the adaptive control system. It is adjusting of the parameters over a time, because this is kind of a feedback mechanism. It won't require any additional input. Okay, so it will be automatically adjusted and it will evaluate. Okay, so in the high-end machineries or manufacturing units, they will go with this type of validation, like the PID control loop and the adaptive control loop and modern predictive control loop, MPC loop. And next we have the cascade control loop and feed for forward control loop. Why we need to understand? So because to understand of the control system and what are the difference it have, so we went into and what are the control system types. So the control system refers to any system that regulates or manages the behavior of another system or the process. So that is a main definition of the control system, and it includes both open loop and closed loop. Means open loop without feedback, closed loop is with feedback system. And what is a open loop and closed loop? It's required. So with the help of the open loop and closed loop system, where we can check the performance and functionality and reliability of the embedded system. So this is a very important for the open loop and closed loop of the system. And next is a open loop. So open loop control system. Open loop control system, we have a system where we are giving the input and we are expecting the output in it. So the what is the input? Input is the command or the set point, like we are making the setting of the values. So if you say the command or input, like we have a the sensor, like the AC and room temperature. You need to adjust your room temperature 24 degrees centigrade, or air cooler, like you are adjusting to 26 degrees centigrade as a air cooler, as specifically you are setting, right? So that will be the part of a set point, so that we are giving to the input to the system. So what is the output? So it will set automatically with the help of the uh, input that you are getting. But to set your point, the system will be processed. So whatever the system we have, it will process the data. Okay, that is the control. If you are setting 24, it should not set 27, 28, right? So whatever you are setting the input, it should be set the output from the controller. So that system will be processed, and output is your result, the output of the system that you are getting. And moreover, the open loop control system is which is not whatever the input you are giving, so it's not dependent on the any activity that you follow, but whatever the input you give, so that only the output will be expected. So in open loop system, the control action is not dependent on the system output or performance. So whatever you will do, you will get it. Okay, so it operates solely based on the input command without considering the actual output or feedback from the system. It won't bother about the output. Okay, so just whatever you will give, you will get it. Example for this is in real time we have a washing machines and the traffic signals. So these are the examples for the open loop control system. And other examples for open system is washing machine. So like how it will operate in the open loop system. So we are presetting the cycle, runs without feedback. So and operates based on the user select, like we are selecting the wash or swing. So the options will be there. So if you give that, the options will be enabled and it will clean the cloths. So it won't worry about whether the wards are fully cleaned or washed. So just it will do the process and it will complete it. And moreover, the heating immense rod, whatever the heats water without temperature feedback. So like you are not adjusting, like you have the heater and just you are making your system to give that heating. You enable the heater, but it keep on continuously heating. So it won't have a set point. Okay, so like if you give the input as a 40 degrees, it will so it will increase the water above 40 also. So that will be the continuous activity will be considered as a open loop. Okay, so that these are some points on the traffic light. It follows the fixed time sequence. So it depends upon the time only the traffic will be adjusted. Okay, it's not about the vehicle's flow. So these are some examples of the open loop system. And coming to the closed loop system, so we have the controller and the system. Means for the system, like imagine this is the system. System is specifically for the lightning or to control the traffic. For that lightening or controlling, we have additionally the controller. So the controller is part of the sensors or any analog inputs and the digital inputs in it. Okay, so with the help of the controller, we are able to control automatically. So from the input, so input is just we are enable on. So once we make it on, so it will go into the controller. So it will take all the analog inputs and digital inputs, and it is a part of the physical or the simulation values in it. So that input we are giving to the system, and if any errors, means that here we'll get the output. So from that, before going to the output, it will verify that okay, the physical value need to adjust. Okay, so like if you say that room temperature, you set it as a 24 degrees centigrade, but the real controller, it will read the informations from the externally, and it will go to the system and saying that the temperature now the input given 24, you need to adjust to 20 degrees centigrades. So that adjustment, if you see the difference is there, like output, it is coming as a 20 degrees centigrades, that is informed by the controller and system. So now it will come here again, and the difference will be there. So that difference will be adjusted again 40, and it will give to the here, and the 424 degrees centigrades will be adjusted. Means, so with the help of this will be coming as a part of a feedback to adjust the error, okay, that we are getting from the system. So any input that it is not going in a proper way to the output, that will be given as a feedback to the input to the controller or the system. So that will be updated. And what is the input? So it is also like the same set point and command will be provided. And controller is to analyze the error. Okay, so based on the error, the controller will determine the appropriate controller action to adjust the system inputs parameters. We are using the controller. And moreover, the system. So system is specifically to process your data. Whatever this is for adjustment purpose we are using, and this is for processing of the data. So like we are using the it will process whenever a process, it will there is a difference. The difference will be updated in the feedback, and it will be adjusted again. It will process and it will give the output. So this is how the output will be validated in the control control loop system. So it is like the uh, closed loop system. It is closed loop system. Okay, so it is in a terms of the control loop system, control system, like it is a closed loop system. Don't get it is the loop here. So it is a control system. In the under control system, we are going through the closed loop. Is it clear? And similarly for the open loop system also, it is same. Like so here, just I mentioned the loop. So it is a open loop control system of open loop system. Don't get confused. Open loop system, and that is a closed loop system. Getting right? And what are the examples for open loop, closed loop system? What under which areas we are using? So control loop system, also known as a feedback control system. So where it will be continuously cycle of sensing and comparing and adjusting the system behavior based on the feedback. Because in real-time industries and all, where the manual presence is not required, the person should monitor and setting of the temperatures, and it's not required. It should automatically adjust, right? So that's why the control loop system, it plays very major role in the embedded system. And it includes the closed loop where the feedback is adjusted. The examples of control system is the PID controller, industrial process they use, and to controlling the room temperature, we are using the control loop system. So it will follow like automatic electric iron. So iron box is a one example. So where it will set some point and it will be automatically turned off, and again whenever the temperature need to rise, it will rise and it will be setting it. So that is a part of the automatic electric iron box. And servo, this is a stabilizer. So how whatever the voltage you are giving to the system, so the voltage will be setted and again it will be adjusted. Suppose you have a stabilizer in home, so you are giving the normally it should support 24 volts. Okay, so whenever you give, it will give the 12 volts to the TV, because it should be stabilized. If you are giving 24 volts, what will happen? So the TV, it will allows only 12 volts, so it will stop that 24. It will kind of a filter it will do, and it will send only 12 volts. It is a kind of the stabilizer where it will be adjusted automatically and it will be centering it. And air conditioner, so air conditioner is also one example of the closed loop system. Overview, what are the like open loop system and closed loop system in terms of testing? So here the performance testing we will do in a open loop testing, and stress testing, and simulation and data generation and functional testing we'll do it in a open loop. And closed loop system, functional testing we'll do, and regulation testing, feedback control validation, and adaptive testing and reliability testing. These are some examples I like to give you. And moreover, in real time, like what is the hardware and what is the software, how we are doing the process for development and testing purpose. Okay, so like we have the mill, sill, and system, bench, and we need to understand the system, how we are connecting, and bench. These are two terms. Okay, so we are familiar, but we'll go through it once again. The mill and sill and hill and wheel. What is this? Okay, so because as a going of a experience, you should be familiar on this, and moreover, to understand how the development will be taking place for the software and hardware designing in the real time, you should get some idea. Okay, so for this, what is a system? So system is a interconnected, it is a collection of the components. So it could be a software system or hardware system or any combination of both. Okay, so we often talking about complex is specifically the individual controllers where we are combining and making some functionality. And it system will be very depends upon the software or the hardware, the complexity that they involved in the project. System level testing. So system level testing is specifically we are verifying with the entire whatever the integration we'll do after integration, we are doing on the system level testing. So system testing is a level of software testing where the complete integration system is tested to evaluate the compliance with the specific requirement. In interviews, if they ask you what is a system testing is a level of a software testing where the complete integrated system is tested. Like that, you need to give the interview. In interviews, they will ask you this definition. You need to give this. What is a system level testing? What is a system testing? So you should be familiar. And the purpose is where we are verifying all the components of because system level, no. So we need to the individual, as I told you like earlier. So system it have a subsystems. Systems it have a subsystems. So these subsystems, it aims to verify all the components of the systems interconnected correctly, and that system is as a whole meet, it is intended function, means whatever the subsystems are combined and making it as a system, and we are doing the system level testing. Okay, so just it have the info like what is the scope, like we are the interfaces between the subsystems or the models we are checking, and the data flow and functionality. So this is a scope. Just I added a point. You are familiar, but we are making the other as aspect as a part of a system level testing. What is the scope? And what is a bench level testing? So bench level, what is a first bench? Bench is referred as a environment or the work. Okay, so whatever the hardware or the CAN case Excel, so because power supply, it all will be a part of the bench. Okay, bench refers the table. Okay, on the table, like we have the ECU, and for the ECU we have a power supply, and sometimes the load box. Okay, and the hill bench, this all will be part of the bench refers to the control testing of the environment or workbench, where I explains on the test and repair, means we usually do the repair or we do the experiments on it, so that we are conducting on the bench. Okay, so like what is a bench testing involves? So where we are testing the components and the subsystems of the large system to control the environment. So that will be a part of a bench testing. So what is a bench level testing? What and all we'll do? So like we used to do the individual components or subsystems, and to ensure that subsystem or component systems are integrated and working fine. Okay, and specifically we focus we simulate the inputs. We are giving the inputs when we are controlling the condition how it is working. So there is a scope. You need to understand what is the system level testing, how we are doing it. And the example for the bench level testing, it includes so where the mechanical component of the sensor, any hardware or software things. So these are we are doing as a part of the bench level testing. Is it clear?
Yes, sir.
Okay. So next is a VHIL. So what it is? So VHIL is a vehicle in loop. Okay. So vehicle in loop or car in loop. So sometimes you need to do the complete system. So testing. So like you need to drive the car and you need to similarly you need to drive the truck. You need to drive the bike also, and you need to take the logs and you need to collect it. So here also VHIL is VHIL vehicle in loop and car in loop. Okay, car in loop also called as a part of complete car testing. So what is a HIL and HIL testing is, it is a real vehicle or physical presentation of the vehicle is integrated into the HIL test setup. Means HIL is a other activity. So we usually configure all the physical components and we are doing the testing. What and all we'll do? Well, like we are checking the safety and reliability and performance of the vehicle on the actual vehicle. So that we call as a VHIL. And vehicle in loop is a specialized from the HIL testing used in the automotive industry to test the vehicle system and components. So what is the definition of this? So vehicle testing involves testing the performance of the safety and reliable in the real world simulation and system. And moreover, the scope is we need to check the complete functionality behavior of the vehicle that includes electronic and mechanical system. And the objective it will be so where we are checking all this because the customer satisfaction is the main objective of the vehicle. And what and all, so road testing, track testing, durability testing, how long we are able to run, how long we can drive the car, so those things we'll do. And environment testing, so these are the methods we follow for. And this is a high level, whatever I am saying now, this is a high level that I'm saying that in VHIL we are doing the testing. And coming to the HIL, so hardware in loop. So hardware in loop, I told you it is a closed loop system. So based upon the feedback, it will be adjusted. So here we have the some controllers, the hardware. So that hardware is specifically for adjust. And this is for the uh, correction or adjust. Will do adjustments or correction we are doing. And this is our the controller to process the data. To process the data, we have the controller here. So it means whatever the inputs we are giving from here, it will be giving to the hardware. So here also hardware and here also one more hardware. So based upon the feedback, it will be adjusted. So hard HIL means hardware in the loop. Okay, HIL means hardware in the loop. You need to write down these running notes. And what is a HIL? HIL is a simulation is a most powerful test method used to test the embedded control system more efficiently. Okay, so while testing the this, we are able to the control system testing of the embedded control system, the safety, availability, and cost consideration is a it will be very important. So I will tell you like what is the purpose of doing this HIL. So if you do the on vehicle, right? So where you need to do the brake testing on the car. Okay. So when you do the brake testing on the car should have a driver. So the driver start doing the brake testing, okay, on the real vehicle. So the brake is not applied properly and the car and the driver get damaged. Means the person also get impact because of the driving and car also get damaged. Here the loss is the human loss and the uh, cost of the car and the components are got lost. So instead of this situation, we can make that same thing in the HIL. Okay, so HIL we have the simulation. Simulation is like it's a kind of a application where we can create the vehicle model and the person we can make into the car and he can drive and he can see whether the braking condition in the software and the ECU is working fine. Just he can drive the vehicle and it can be verified. Okay, if any why braking is not up happened, so that can be debugged and identified and fixed very quickly on the HIL. But in the real vehicle, it cannot possible. So that's why And the hill testing is a familiar where we can save the cost, where we can save the time, where we can uh, overcome out of the uh, panic situations like the persons are getting damaged or the car vehicles get damaging. And the development of the softwares, it will be very easier in the terms of the hill. So there is a purpose, the hill we are using it. And usually the hill configuration, functional architecture, it have the IOs. Okay, so and the host. So here the IO host is our PC. Okay, so this is a PC. In the PC system, we have a data manager and the model managers and test sequence and analyzing we'll do on the lab PC. And these are some part of the hardwares. And this is some space of IOs. And we have actually the ECUs are connected to understand in detail like what are the hardwares it have and what are the IOs it have and what are the ECUs. So it will be the functional architecture. Means this many channels and the IOs hardwares are required to ensure that the testing of the hill. Okay, so how whenever we need to do some the software development or hardware design, so the first will be the modeling loop. So modeling loop, like what are the options you should be considered. So that will be part of a model loop, and that logic will be configured, and virtually they will do because we don't want to make in the real. So it will be in a software in loop. First, it will be the modeling loop, software in loop, and this means whatever the logic we made, it will be converted to the software in loop. So once this is completed, the software is now ready. Just we are transferring the data into the hardware. So that hardware the is called a hardware in loop, and moreover the real world, when this is working, then we'll give into the real world. Okay, so like whatever the development we do for the hardware things, so first we'll make it in a virtual software. So that is a software in loop that we are making in the modeling, and we are doing. Okay, what is a modeling loop and how the software in loop and how the hardware in loop takes place? So generally, the hardware we need to understand. The hardware is specifically the CPU or memory or storages and input-output devices that talks about the analog inputs or digital inputs, just for exchanging of the communication. And the hardware here, it is used for the functionality of the working, and moreover we are able to perform the specific task with respect to the software. And in loop hardware, in loop means specifically the program, it will be keep on executing the instructions. So that is a part of a in loop. Okay, and until the condition satisfied, it will be automatically repeat the task. So if any failures is happened, then it will be ended up. So what is a simulation? Simulation is a technique that mimics the real world process using the computer model or the physical representation. Like you are aware, so like you have a camera. Okay, so you have a camera, you have a captured some of the image. Okay, so image is the physical image, and but when you capture into the camera and you are able to see in the gallery, that is a part of the physical representation, right? So it is a physical replica, means whatever the photo you are doing, that is a you are seeing on the gallery, it is in a application. So here also it is a kind of the same, the whatever the physical hardware, like the motor or the gear acceleration or the car that we are making in the physical. So just we are converting into the physical replica, means into the simulation way, that with help of some tools. So like MATLAB or some other tools we have. So with the help of that, we are whatever physical things. So we are making as a same as the here in a simulation we do, because it is a difficult to test in the real time, right? So um, so to ensure that real cars or the hardwares or the motors, it will be getting damaged. So I will make it as in a simulation way, because software don't know whether my software, my interaction, whatever I am doing in the real motor or real car, it's not. So it will feel that it is in a it is communicating with the similar real world. Okay, but software need to understand. Okay, so every time it should be in the real contact of the hardwares. But when we do the simulation also, it will feel the same. The software is thinking that it will be in the real connectivity hardware. So that's what simulation is, a technique that mimics the real world process. So using the computer model or the physical replica in it. So this is what the simulation. So hardware in loop simulation. So allowing for the safe experiment and analyzing of the complex software that we use the simulation. And what is the purpose of simulation help? So it will help us to predict what is the exactly it will be happened in the real world application when we are driving the real car, and what are the problems we'll get it. So that will help with the help of the simulation, it can be achieved. And moreover, it will be the deviation phase or any critical situation, we are able to understand very quickly and we can improve it. Okay, what is a model? So model is specifically the blocks where we are creating and to implement the software. Specific algorithms should be performed. Like who are familiar with the physics, so here we have a mass and we have the weight here. So it is a hanging, and it is like a spring, and it is have a some pressure in it. Like we are have a tool, so of the same. So that is a spring and the mass and the connectivity point. Okay, so whenever you need to push some button or thing, so you for this you are creating in the model, you need to understand this flow, and then you create a formula. Based upon the formula, you deriving the model. So this is a part of the control system. Okay, so control system, who are familiar with system engineering and the model creation and the plant model creation, the developers will do this. So this is a model specifically where we usually do. So because here we need some adjustment of the sensor. Okay, so sensor or the injector or the fuel injector, we can say. Okay, so where you need to make some algorithm. Okay, so I don't have the physical thing, I need to make a simulation way. So in the simulation way, we can see we can implement this block, addition block. This is a gain block. So gain block is the whatever the value you are making to input. So, okay, so this is a step block. So like we'll give it in a model, and we are making as a simulation. And so it have different tools. Like we can use the NI view for simulating this, and we have the maps of MAPL, Anki, and MathWorks, Easter, Eckhart, and NI. These are the some dynamic like models we can create in these different tools and different. And model in loop is specifically it talks about MIL testing is a crucial part of model-based development. Because someone can create the model, but we need to test, right, ensure that whatever the inputs we are giving, it's working or not. So it starts by creating the diagrammatic in the real world with the help of the MATLAB Simulink, and we need to check the specific logics are working or not. So this will be a part of a plant model. Okay, so simulated plant model. You need to remember. So whatever the plant model means, so the plant model, it have all the logical algorithms like addition, multiplication, and just we are giving the values in it, the set values, and we have the algorithms to make the changes in it, and we have the multi switches. So these are part of a plant model. Okay, so whatever the input we are giving to the controller, so we don't have the physical component, but we are making in the Simulink plant model. Okay, and
So,
sorry,
sorry to disturb. Like in
yeah,
Hill, right? So like
hmm?
in Hill concept, right? Whatever you said now, right?
Hmm.
So
Yes,
like correct me if I am wrong. So that
hmm.
particular brake system which you have explained.
Hmm.
So that in real world, like while doing Hill, we are taking out the ECU and connecting in loop, and we are testing. That's correct, right?
So like you need to check the braking system. Okay, braking system is a one feature you implemented in the controller. Okay, like it is a EPB. EPB is electronic braking system, you can say. For this uh, parking braking. So like this is a ECU. So you need to check the future of this braking system to the software. So you cannot directly go the ECU and directly plug into the car. You cannot do the testing, right? So that is a difficult. So for doing this, what you will do, you will create some plant model that is a simulation way. Okay, in that simulation way, they have a controlling of the braking. Okay, apply the brakes and increase the speed, and you can see that information. It is like a GUI, like CANoe, how you apply the brake and do no. So similarly, you will apply the brake and you can see whether the braking is working fine or not. So here, whatever the simulation we are doing, that will be in the modeling loop. Okay, that is specifically for the HIL components we are doing in the modeling testing.
Yes, sir, like that particular ECU only we're connecting in that hardware loop, and we're testing.
Yes. Yes. We are connecting the particular ECU and we are doing the, because we need to test the software, right? So that's the reason.
We used to test like ECU. With
Software, not ECU. The software which present in the ECU, we are testing it. We need to check that software behavior. So whether the braking is working or not. Okay. So computer based model to simulate the, like in the model, we are testing the behavior and we are doing the whatever the design we are making, it is a correct or not. So if we are able to identify the errors in it earlier, so that will be a part of a modeling loop. So before in V model, like whatever the SIL software in loop, hardware in loop, before this we are doing the model testing. This is the first phase. Okay, so these are the same like we used to do the early stages in the validation. Next, coming to the SIL software in loop, it is a development and testing of the embedded software. So whatever the plant, right? So the model we took it. Now the model you need to give into the controller and you need to test it because that is a simulation platform. Simulation means where the physical thing will be there. That physically thing we created as a model. Now we take the injector or the sensor. Okay, now I have a sensor. I need to keep that sensor in the real world. Okay, I need to check it because now the sensor I don't have. I created in the model the sensor. Now that sensor is working in the software or not, I need to verify it. Okay, so now coming into the software in loop is a simulation method used in the development and testing of the embedded system. Mostly it is controlled by the simulation way. Okay, so we are checking the complete the code, means whatever we are doing in the model, so that will be coming in the part of the code level. Okay, like .c .programming, it will be added. So SIL testing is specifically the same function, like where we are checking the functionality and behavior and performance of the complete system. Because whatever we are doing the modeling, no, there also we are checking the functionality and behavior and performance. So in the SIL testing also, we need to do this. So this is very important to hear because to detect the early errors. And the processor in loop. So processor in loop is specifically the pill we say. So whatever the code we have means we converted the model. Okay, and from the model it has some block diagram of this. If else, this is a condition. If else, if this is not working, it should work. So like we converted into the code. So in code we have if and else logic. So now I need to see this if else condition is not working. So I connected to this into the controller directly. So with help of the tools or any protocol like UART or CAN, anything. So like we are running the model. So whatever the model or code it's implemented, it is working on the controller or not, just we are ensuring it. Okay, so it is a method where the controller code is run on the real processor when connecting to simulation of the physical component. It is controlled. Okay, this is this and all in interviews. They won't ask you much, but it's knowledge to understand you what is a pill, what is a hill, what is a the cell, all those things. Okay, so this allows for the real world testing and validation of the control code functionality without needing the physical system. Okay, we don't want any physical system, just we are whatever the model or the software we have, with the help of that we are doing it. Next, coming to the hardware in loop. So as we discussed, HIL simulation is a most powerful test method used to test the embedded control system. Okay, it have the hardware and software, because the software and hardware is a complex system. Okay, so we need to check the performance and reliability in it. So this HIL is a mechanism you need to understand. It have the complex hardware and software, and where we are doing the validation of the software, we are testing the software in it. Okay, so in coming to the V model, so we are familiar that design phases, we have a system requirements, system architecture, software requirement, software architecture, software component. Okay, so what is the software system requirement? So it's all about the CRS or BRS will be there. So based upon that, we'll do some analysis. Okay, and next we'll have the software testing, means we have the high level design and low level design in it. So again, that will be low level to high level design. So that will be whatever the software is done design, they will implement the coding will be done, and that will be performed. It is a kind of the integration we'll do, and this is a system component, means whatever individual like low level design, like unit level things that we are making as a unit level testing, integration testing, software testing, qualification testing, system integration testing, and system qualifications, just to understand like how the process. Okay, this V model you don't want to explain, whatever I told you in the testing process, right? So that you can explain the V model. Why this I explained you, because to in the application, like whatever the mill sill hill we learned, no? So where and all it will be coming as a part of a V model. So it is a requirement analysis, we are going to design it, and we design the component design, and code implementation will be happen. Okay, so this is a part of a design phase, and this is for part of the testing phase. Okay, design and development will be taking place in this side, and verification validation will be taking in this place. So this is just for our understanding. Okay, so so whatever the model mill we say. So here the first phase, it will be covered from the requirement analysis and system design, that will be covered as a part of a model in loop, and software is ready. Now the implementation is ready, and vehicle in loop, hardware in loop and vehicle in loop will be taking place. So this is the activity, means to make sure the order. Okay, how this order will be take, model in loop, software in loop, and hill loop, and vehicle in loop. This is the order it will be followed. So to understand you that process of the mill seal hill, just giving you this kind of a V model kind of thing it will be. And next is when we are doing the testing, right? Like the functional code, or the controller, or the active safety system, or the vehicle dynamics, or driver, and environment, or traffic, anything that whatever we are doing it, right? So like V stand for the virtual, R for the real. Okay, so like whatever you are making as the real hill. So if you see the hill, we have a real controller, real code will be there. So remaining active safety system are the vehicle dynamics, driver, and environment, traffic. This and all we need to create virtually, because we cannot simulate the real traffic, right? So we need to be in the simulation. And moreover, if you see the VHIL, so VHIL is also same, like we have the active safety system, vehicle dynamics, all are real, but only the driver may not, it will be. So traffic and environment, we need to create a virtual, means whichever it is not possible in the physical way, that we are creating in the virtual, and the real things we are making in the real way. So just to understand you, or like the what, why, when we needed the real and when we need the virtual. Okay. And next we say what is a HIL? HIL short form is a hardware in loop. So it, what and all it involves? So it involves the real hardware components such as a controller, actuator, sensors, and it is simulated with the software simulation to validate the performance and the behavior of the large system. So this is the notes, like you need to write down what is a HIL. Okay, so next is how this work in the real time. So whenever we have the operating place, so the operating place means the whatever the tools, software tools, just we have, and the hardware things that we are making control. So that we have it in an operator interface. So just we are giving to the hill bench. So hill bench is anything like a dSPACE or NI, Opalati or a Speedo, and the Kangest. So these are some benches which have the hill. So what it will do, it will process the data, and it will give to the IO. So means it is a IO space communication we have. So to that is communicating with the ECU, that is our real-time controller. From the controller, we have a feedback. That feedback will be given to the hill. So based upon the feedback of the hill, it will be adjusted, and we and it again it will give to the ECU, and again it will go have the feedbacks. Means everything that looping will be there continuously for the hill to work when we are working with the hill based system. You are able to understand why we needed hill.
So,
Okay, good. Next is the point. What are the key components is required for the hill bench? Okay. So in interviews might ask you. So first is the operator interface. That is our PC. Okay, lab PC. We usually say no, that PC is required. And next is the power supply. And next is the ECU and bus control system, means IOS, and real time processor, and input outputs channels. Okay, so these are the components required for the hill bench, and sensors and actuators. Okay, so these are the key components that required for the hill. Okay, so is it clear? So you are able to express, right, in interviews, like what are the components it have. So what is a hill? What are the components we have? You need to aware. And so in hill, I told you, like the first phase will be the real-time processor unit. So what it will do? It will process the data. Okay, so it will manages the IO, it will communicate the data, and it will take the logs, and it will store the data. So the whatever the physical real-time things that is required, so that will be able to capture, and it will be storing in it. Okay, so sensor actuators, and like whatever the sensors actuators are interfaced to the ECU, that will be collecting, and even the virtual environment that we are simulating with the model. So even that data also, it will be captured and it will be stored in the processor. So processor is specifically to process the data and it store it. Next, it's a part of a IO interface. So it is used to take the analog data and digital data, and it able to simulate the signals, and it will manage with the IOs and the sensors, and it's specifically the voltage related also, it will be communicated and exchanged. And this is the same like the analog and digital and bus signals, and the real controlling information it will be captured. Next is what are the software interface. So the software interfaces are the way we are writing the test cases, whether in a CAPL scripting or VT system or Python. And next, the ECU simulation. So specifically, the tools will be there, because with the help of the tools only we are able to interact with the hardware. No? So that is for the software interface. So like CANoe, and in the CANoe, how we are running the test cases, how we are making the system to interact. No? Similarly, here also the software interface. So here it's specifically for the HIL. We are using the dSPACE, or for the CANoe, we are using the vector to simulation. And device under test, we are familiar, where we are connecting with the ECU and we are doing the testing. And what are the essential components? So the controller, simulation, I/O interface. Just I given a brief points here about all the what is a controller, what is a simulation, what is the I/O, what is the sensors, and what are the sensors it have, what is the actuators, like relays, motors, switches are part of the actuators, and what are the other things is the signal conditioning unit and power supplies, and data acquisition system is a collecting of the data and recording of the data, and the monitoring of the software, so configuring monitoring of the system, and load means externally we need to connect some loads to the ECUs. Okay, so next is a safety system. So simulation models and communication bus interface, and the racks and cabinets will be there, and cabling and wiring. So generally, to the simple bench connectivity to show you, the hill be previous slide show you, but to make you here, the power supply will be there, and by hill bench and the PC, and the ECU will be there, and here we have the harness. So this is how the hill bench will be connected in the real time. Okay, is it clear? So here I given what is the hardware input. So it will mimic the same whatever we discussed. So it will mimic the complete real world system by using the mathematical model. Okay, and next is how we are controlling and towards the hardware and software. Uh, so just I given here. Um, yeah, what is a hill testing? So just it is a the repeated point to ensure on the vehicle level what we are doing. So you need to understand what is the purpose, scope, benefit. I explained it here. So next, what are the IOs it required? So real-time inputs and control output devices. So what kind of tests we are doing on the hill? Like we are doing on the hardware-related testing and application-related software testing and communication reliable testing. These are the three important points you should be familiar. And fault injection, like what kind of hardware testings are done in the hill in detail. So hardware fault injection. So we are making the this is our interface PC, and here we have the hill, and we have a HIO. So the fault injections will be there. So with the help of the fault injection, we are able to do short to battery, short to ground, and we need to see how the ECU system is changing whenever we are creating the faults on the hardware level. Okay. So what are the list of hardware tests we'll do? So short to ground, short to battery, open circuit, over voltage or under voltage, RAM test, EEPROM test, sensor range, means an invalid and invalid values, software application stability, testing of the CAN signals and the diagnostics, CAN bus off. So these are the hardware interaction, we'll do shorting of the battery, shorting of the ground, whether the UDS is in 19 service, whether we are able to read the fault or not. So those are the kind of hardware fault insertion. We'll do it in the hill bench. And RAM test is when we are running for the long time. So we'll have the variable. With the help of the variable, we can see how much memory is utilizing. So that is a kind of a RAM test. We need to, as a tester, we need to ensure whatever the software we are developing, it is not impacting on the hardware. So that we need to do on the hill testing. Is it clear? So this is some example I given of about the motor. So how the voltage and like for the motor, what are the necessary things we need? We need the sensor in input. We need to give simulate the output, and we need to give the voltage and current to be ensured. These are to perform the motor. We need a specific means the top is a fan, but bottom we have a motor. So motor makes the fan to rotate. Okay, we need to give the proper voltage to rotate. If not, it will be damaged. So just I given like what are the motors, or like for the motor how we are generating. So we have a three-phase indication, three phases A, B, C. So and this is a part of a drivers. So for driving these three-phase voltages, like we are simulating from the controller. So how we need to simulate what are the pulses we require. So that is a pulse with modulation signals we require, and we are generating it from here, and that will be given to the motor. And next will be part of what are the challenges we'll face. Yes, we'll face the challenges like a modeling issue and timing related, because whenever we give the input, it won't reflect in the software instantly. So those are the challenges. And coming to the hardware software integration, will face some challenges, and realistic simulation also will towards the MATLAB thing will play. The MATLAB or simulation we'll doing. So there also will get some problems. Okay, and the model complexity and time synchronization. So and data acquisition, we're not able to capture the data on time. So some scenarios will get the faces will faces the challenges, and we're doing the field testing. And during the test coverage and design, all and hardware fault emulation and the cost relation. So, like we usually face some challenges when we are working on those areas. So, just I given what is a fault, hardware fault emulation. So, fault detection and responses the realistic hardware fault emulation tool, injecting the sensor and activating the failure in it. So, just I given brief info. Because in all those areas, we'll face the challenges when we are working it. So advantages of HIL, it will be a realistic simulation, and it will give, we can do earlier validation before releasing to the market. And next is a cost we can save, and repeatedly we can do the testing. Like you need to open the airbag, we can, because one time the airbag is fixed in the car, you cannot repair. Okay, so the entire setup we need to repair. It will be difficult in the real time. So when it is in a hill, we can open multiple times and we can do the testing. And safety is a very important, and integration testing we can do easily. And disadvantage of the hill is complex setup, and limitation where, and the model accuracy should be required, and dynamic model changes, and limited explore of the edges cases, and maintenance upkeep. Okay, so like we have different benches, the different vendors. Like the Vector is a one company, like they will also provide the hill bench. NI is a one bench, they will also one provide the bench, and the dSPACE and Opality. So these are the four I mentioned as a top. These are the top four hill pieces like we are using in the automotive industry. Okay, if someone asks you like when you are attending interview, like you worked on this space, you are able to take the vector or opalatic bench we have, you are able to work. Yes, you need to say, because the benches, hardware, processor, IOs are same. Okay, only the difference is the company vendors will be same. Vendors will be differ. Remaining thing, cards or the IO connectivity or the in whatever we need to do on the bench level, it will be the same. Okay, load box usually it contains all the digital inputs. So these are the digital inputs, like the switches kind of thing, and analog like inputs, like we need to vary like the fan indicator. So the, and next we have the power and the ground. Okay, whatever the blue ones you are able to see, right? So these are part of the ground, and the green ones are the batteries. Okay, So here again, this is for the digital things. For another thing, it will have the power and ground. Okay. So like similarly, like whenever you need to do short to battery, short to ground, you will take the wire and you need to plug in it. So that is your short to battery ground. And what is a load box? So we can simulate the inputs and outputs, and the sensors and the actuators will be there that have the digital inputs and digital outputs, and pulse width modulations and analog inputs, communication interfaces, and we harness will be there. Whatever the group of wires we have harness, and what is the using? Otherwise, we are able to do the testing and development very easily with the help of the load box. And breakout box, it is like same, but only the thing is, it is breaking the information. Like suppose, um, imagine this is a load box and we have a ECU. So the breakout box you are keeping in between, whatever the harness you are giving here to the ECU directly, in between we are taking the breakout box, because A to A1, A1 to A2, you need to give the connection. This here we have a A1 and A2. Okay, so now similarly, instead of that A1, A2, you'll give like this connectivity. From here, you will take this. Okay, now it is working fine. Whenever here I have one switch, switch is on. Switch on means A1, A2 connect. Switch off means A1, A2 disconnect. I will give you the notes for all this. Okay, so the HIL testing on this, just you need to listen what it is. Okay, just it is an introduction only. So whenever the switch we are making on, A1, A2 will be connected and it will go to the ECU. If it not, it will be disconnected. Why we need to do this? Because in the real time also, wire can break. What is the how the system can work? So we need to validate this. So for doing this, we are using the breakout box. Okay, so breakout box is for connecting with the ECU and disconnecting with the uh, sensors or the switches in between to operate, okay, from the real world. Okay, so the signal, we are able to access the signals, we can be able to do the diagnostics, and we are able to see the communication related protocols also, we are able to handle it. And power supply, the power supply is the one where we can break down the power supply and we can supply it, and the LED indicator. So these are high more in detail. Okay, we in real world we don't use much, but to understand with the breakout box, what are the inputs, it can take how the output can act. So just I given this safety precautions, manufacturer manual. So this all be considered as a part of a gray box. And like single ECU, how we are able to connect. So here, this is my single ECU in the cars which we connect. So these are the group of wires. Okay, whatever the harness we say. So like this from the PC, real volt and high volt, and with the help of the harness, we are connecting to the ECU. What this harness contains, this many wires, it contains all the analog and digital bus interfaces. So this is a single ECU. Okay, I need to connect, check the multiple ECUs. Similarly, with the help of the HIVOs, where I can connect the multiple ECUs and can do the testing. This is a multi-ECU connections. Is it clear? And if you have the like, I need to make the processor like the hill benches, multiple hill benches. So multiple hill benches, you need to connect with the help of the IOs to the different users, and you can do the testing. And you need to do the IO separately for each issues. You can split it among the processor like separately, and it will be easier for us to know that okay, which IOs for which ECU it is going. So like that, it is a simplified wiring and distributed the IOs independently. How to integrate ECUs to the HIL? So this just for you can go through this recording or the points. So first you need to get the requirement. Based upon the requirement, you need to set up the environment, like what is the hill, and you need to additionally what are the IOs, what are the controller it have, and then the ECU configuration you need to do. Then you need to establish the communication protocols and configuring of the interfaces, both the hill and ECUs. And you need to create a scenario for testing your hill and the ECU. You have a specifically develop the scenario, and you need to execute the test case, and you need to troubleshoot and debug it, and then you need to check the performance, and you need to make a document, and then you can verify and validate, and you can deploy and saying that your bench is working. So that's how you need to integrate the ECU to the hill. What are the sensor circuit are connected in the hill? How to check whether the sensors are connected or not? So you need to check the signal conditioning. What is the real values? We are able to read it on the tool like CANoe tool. So that you need to see, and you need to connect the input channel. So respective channel, the sensors are the input to the controllers. So outputs are the actuators. You need to vary the sensors, and you need to verify the output whether the sensors are correcting or not. And if not, you need to simulate it. And all are like, what are the sensors? Different types of sensors: temperature sensor, pressure sensor, position sensors, acceleration and voltage and current sensors, speed sensors, force and flow sensor. Fuel sensors are the flow sensor, and force and level sensors. So these are types of the sensors. And digital and analog inputs, so we are giving to the control hill, and customize the sensor. We can customize the sensors and simulate the simulation we can do. If you don't have the real sensors, we need to customize and we can simulate the sensors. So, and we are giving the external interfaces. Okay, so is it clear for you all? So these are testing techniques, like whenever you usually follow for equivalence partition. So what is the steps you should follow as a part of the testing techniques? Okay, so you can verify this. So equivalence partition, I given you one requirement here. Okay, so the range, and you how you are dividing, and how you are dividing the values. So how many test cases you are writing it. Okay, so just go through it. And next, have a boundary value analysis. So boundary value analysis also apply the same. Okay, so the boundary value here is okay, so here I given the values of so how many test cases we can write for the minimum and maximum values. So for negative and positive scenarios, I explained. Okay, so this is a equivalence class partitioning, and yeah, so these are the equivalent, like how the values are divided among. And next we have the state transition. So state transition is specifically, it talks about how the changes will be happening from the temperature. Okay, so just to go through these steps. These are very important steps, I can say. Okay, in real time, we what usually we'll do the testing. Okay, so I will present it again. So this is a equivalence class partitioning. So you can go through it. And next is the boundary value. New one requirement here. Okay, so the range, and you how you are dividing, and how you are dividing the values. So how many test cases you are writing it. Okay, so just go through it. And next, have a boundary value analysis. So boundary value analysis also apply the same. Okay, so the boundary value here is okay, so here I given the values of